All right. So, hi, I'm Kathleen O'Donnell. I'm co-director of programs here at ISPI SoCal, and we always like to let people know what's coming up for them to be able to join. So I'll direct your attention to the right side of the screen. So last Friday we had our roundtable on striving for excellence, not perfection, and that was a great engaging dialogue. That's more of a interactive session. Today we have our extending value by thinking deeply with Rob, and we'll learn more about that. Next month on February 1st, the Tuesday webinar at this time will be on micro-learning and making sure that that is you're doing it in an effective way. And then in March, we've scheduled with Will Falheimer. We're still settling on the topic, but it will be around evaluation. And I'd like to just remind people that if you have ideas for roundtable articles, for webinar guests, if you would like to speak, if you would like to contribute some of your skills through our chapter activity, contact Vince. I've got his email there, and I'm sure, Vince, you will put your email into chat so people can contact you if they would like to. So with that, I'm going to stop sharing and introduce today's session. So I'm really happy to introduce today Rob Foshay, who's going to talk to us and dialogue with us about thinking deeper. Rob is a storied history here, consults on human performance technology, performance-based assessment, instructional design, founding member and practice leader for Hale Associates, and some of you might remember Judy Hale was here a few months ago. Deep experience in the private sector. I'm going to just mention Texas Instruments, VP of Plato Learning. Some of you might have heard of that and used it. He serves on the faculties of the University of North Texas and Walden University. Life member of ISPI and co-creator of the ISPI CPT program. So some of you may have been through that. You can thank Rob or not. And he's a frequent presenter and author. So we're welcoming Rob back today to dialogue with us, because we had him present at the end of last year about critical thinking and how to do that well. And the ensuing conversation just made us realize that there was so much more to dig into, that he was really generous enough to agree to come back and have a dialogue with us today. So we're really interested in this format and excited about it. So, and it doesn't matter if you were in the last session or not. So there's how the flow will go today is, so Rob is going to start off, just kind of kick off some key concepts, so we're kind of all on the same page, and I'll start by asking some questions to kind of kick off the dialogue. And then as we go along, go ahead and use chat to put in any questions or observations that you have, and then we'll be pausing and going in. Vince and Miller will look for those and bring them up, and we'll even have you come off mute to participate in that dialogue. So with that, Rob, if you are ready, we will get started.
Fantastic.
Awesome.
And thanks again for inviting me back. Let me just run through a couple of slides that we used last time, just to refresh your memory a little bit, if you were there. This would be nice if I could see. Are you seeing any? No, I'm just.
It's coming. It's not here yet.
Patience.
It's still very weird. Okay, well, it's supposed to be showing.
There we are. We're here. We got it.
Okay, there we are. Now we're back. Technology is wonderful. Anyway, this is where I always like to start. But the just to kind of refresh your categories a little bit, what are we talking about with critical thinking? I think we're talking about a number of things. There are critical thinking beliefs, which is an attitude, a critical thinking attitude, an attitude to think, to keep asking yourself, how do I know this, or why do I think this is true? That's part of it, and underlying that are scientific argumentation skills, the ability to formally build an evidence-based argument, and which in turn are and those skills are in turn based on formal logic in philosophy and in mathematics. And underlying all of those is domain knowledge. And domain knowledge plays a critical role. There is no such thing as general critical thinking, as a general critical thinking skill of any kind. It only exists within a domain. So it's quite possible to be careful or to be capable of doing critical thinking within a domain where you have good domain knowledge. It's also quite possible, however, that you cannot do the same thing in a domain that's completely new to you. Similarly, it's quite possible to have your domain knowledge organized in a way that either facilitates or inhibits critical thinking. And that has to do, that has an implication that it is critical to teach domain knowledge in the right way, to teach it in a way that is organized for the purpose of doing a particular kind of critical thinking. So we can talk as much about any of that as you want to, but keep in mind, a number of years ago, more than 20 years ago now, a famous researcher, psychological researcher, cognitive psychologist named James Greeno, started out a talk on the state of the art of the field by saying, we know enough to do damage. And one of the things he was talking about was, we know enough to teach domain knowledge in a way that we know will prevent people from ever being able to use it for critical thinking. And that has a bunch of implications. We know a lot less about how to do it right, but I think we do know some things. So what are the benefits? I think there are a number of benefits for critical thinking. One is that you can use it to challenge beliefs or mere summaries, and this is both in your own knowledge and also in others. You can tell the difference between a critical assessment and a summary, and accepting other people's assertions as without assessment. You can spot and correct misconceptions. Misconceptions are critical. This is what Will Rogers was talking about in that first slide. The idea is that we have misconceptions all of the time, all over the place, and about all kinds of things. And the corollary, there are two corollaries of that are important. One is that if you have a misconception, then it's not that you don't know something, it's that you know something that isn't true. That in turn means that if you make a mistake, it's not because it was a guess, it's not because it was random, it's not because it was careless. Many times, if not most times, it's because something you thought was true is not true. In other words, you caused a misconception caused you to make that mistake. That has profound implications in terms of how you teach things. Another point here is that critical thinking, in all its forms, is a foundation for innovation, and that this is true at every level in an organization. The familiar top-down traditional model, in which only the senior managers are the ones that are capable of doing innovation or allowing innovation, even, and everyone else is simply there to execute. Is first of all, probably never was true, but it certainly is not true now. And in point of view, and in point of fact, is now dangerous. That's if your organization is built like that, so that only the people at the top are allowed to innovate, then your organization will die. It's incapable of innovation. So innovation has to occur at every level in the organization all the time, which means, therefore, that everybody in the organization at every level has to be capable of critical thinking. It also means that everybody at every level in the organization has to have a shared understanding of what the domain knowledge is for your organization. And that's critical too. Now we could keep going about those things if you want anytime, but that's what we did last time. Why don't we instead go to start talking about examples? Because after all, examples are the best form of teaching. So Kathy, I know you have identified a whole bunch of real interesting questions, and we can trade war stories for at least the rest of the afternoon if you want.
Yeah, I was going to go with the kind of dive in directly to value, but you had mentioned some benefits, and I want to get into some of this example stuff because, and you had mentioned a really interesting one, I think in one of our exchanges, and it related to Silicon Valley culture. I think we're going to get maybe into innovation here and maintaining the status quo versus challenging it, right? But you had mentioned that in Silicon Valley culture, and where I am, it's Silicon Beach, but where any problem that can be described can be solved algorithmically. So if you can't develop an algorithm to solve it, you haven't adequately defined the problem. So it doesn't exist. So, what's your concern with that? And I mean, we can go further on examples, but I kind of like that one. Yeah.
Well, the issue there is that that's only one kind of problem solving.
Right.
And there are many kinds of problem solving. That doesn't allow for creativity, or allows for only certain kinds of creativity. For example, a long time ago, in one of the first books written on this whole issue of problem solving, back in the 1960s, a distinction was made between problems that have a known solution and problems that do not have a known solution, or problems that have many possible satisfactory solutions. And the task in solving the problem, the first task in solving the problem, is to define what the goal is. Well, if that's the case, then that's a class of problem solving, which you start there. You start by figuring out what the goal is, or what would an acceptable solution look like. Lots of engineering works that way. That's why engineering is a creative process, and so on. So lots and lots of possibilities like that. By the way, same thing is true for say medical diagnosis. Lots of medicine. One of the criticisms of medicine is that doctors are trained in what's called allopathic medicine, meaning they are disease killers, and they're trained as disease killers. Well, okay, that's a defined goal. Either you've got a disease or you don't. That's fine. But what happens if there is no disease? What happens if the problem is vague or cannot be defined in terms of disease? And that includes things like chronic pain. It includes things like chronic fatigue syndrome. It includes all kinds of physical disabilities where the goal and includes in many cases things like palliative care, where the goal is the problem is not to define a disease and kill it. The problem is to optimize quality of life in some way. That means you have to understand what quality of life means for that patient, and then you have to understand how to optimize it, and so on. Other kinds of examples, say mental illness. If you've ever read any of Oliver Sacks's work, the thing that distinguished his approach to mental illness from others is that he did not say mental illness is a disease to be killed, and that there's, quote, a normal state. What he said is, these are simply, this brain is functioning, and this person is functioning, but we have to understand how. And and the goal is to optimize life, for that quality of life for that person with the disease, or with the brain that functions the way they do, and then go from there. So he learned how to understand what we call mental illness from his point of view, or from the patient's point of view, which is, it's not an illness at all, it's just me. And then so the answer is, and so the challenge is, help me live a better life.
Oh, okay.
Yeah, somebody needs to be on mute, I think.
So lots of possibilities there. Same thing, by the way, is true in engineering. It's true in medicine. It's true in architecture. It's true in all kinds of fields.
Erwin, do you have your hand up? Did you want to?
I do. So Rob, you know, there's a class of problems like the sort of well-known nine dot problem where the solution requires people to think outside of the box that they're presented with. And if you look at Facebook, there are lots of examples of people being presented with very simple looking problems who cannot solve those problems. Whereas the solution usually is to look outside the structure of the simple problem. How does critical thinking play a role in dealing with kind of mental set or the limits people impose on themselves?
It allows you to, critical thinking, well, there are a couple of things operating in that kind of case. The first is, if your domain knowledge is organized procedurally, so that what you have learned to do is to follow procedures, then the first thing you do when solving a problem is to say, have I ever seen this before? And if the answer, and then the question is, if the answer is yes, then how did I solve it last time? And you simply recall that solution and do it again. And the problem with that is that suppose this problem looks like one you've solved before, but isn't one you've solved before. That will cause you to make an error of a kind that only an expert problem solver can make. So that's that's one issue. The second issue is that what critical thinking will give you is so domain knowledge organization is one piece of it. Another piece of it has to do with cognitive strategy and the ability to understand and to think critically about the cognitive strategy that you are using right now. That's called metacognition. And so what critical thinking is all about, the attitude of critical thinking is about asking yourself, am I using the right cognitive strategy to solve this right now? And that, by the way, again, is true at every level. It's true anytime you're learning something. If you are a good critical learner, you ask yourself, okay, I'm trying to learn this thing. Am I using a productive strategy to learn this? And if the answer is I'm not getting it, there are a couple of possibilities. One is you say, I'm just dumb, I'm never going to get it. And you throw up your hands and quit. That's one possibility. Another possibility is to say, well, I got to find a different way to think about this. And then go from there. And it's a when people talk about critical thinking, therefore, they also lots of times talk about metacognition as a critical piece of it.
Well, I guess the other component of that is there are a lot of cognitive biases that operate in people. Sure. And in some ways, it seems like critical thinking in and of itself won't get people to see what they can't see, given that they think they know that sphere of the world.
You have to understand, once again, sure, absolutely. Once again, if your domain knowledge has been organized incorrectly or organized procedurally, especially, then you will not be able to get outside it. And that's a problem. That, for example, if you don't have a deep conceptual understanding of the domain that you're in, that will be a problem. One of the early examples of that, or one really great example of that, has to do with the question of why is it that most kids, like 60% of kids, do not succeed in Algebra 1. This is a problem that has been researched actively since the 1970s. And one of the things that was found was that the reason is that it has to do with the way elementary math is taught. It's often taught procedurally. That is to say, you have a problem, it looks like this, you see an equal sign, you solve. And you solve using defined manipulations that are allowed when you have that kind of a problem, and so on. And why it all works, who cares, and who knows and who cares. The problem with that is that you get to algebra, and guess what? The meaning of an equal sign changes. The structure of an equation, the balanced structure of an equation becomes important. Kids, first of all, crash and burn not when they hit algebra, but when they hit fractions. And if they never get past fractions, if they never understand fractions conceptually, which means they never understand number theory, then they cannot deal with algebra. And so the conclusion that emerged by the 1980s was that the reason kids were failing in algebra was because of the way elementary math was taught. It took another generation until the next generation, until the NCSS math standards, for that to become really built into math learning standards for elementary practice, and math teaching in elementary schools still has not changed adequately. Why? Because the teachers themselves were not taught how to teach math conceptually. And the estimates now are that only a small minority of kids are ever taught math conceptually and at the elementary level, and then they have trouble with it the whole rest of their life.
Oh my goodness.
And that's why it is that they never make it through Algebra 1, and that's why it is that they never make it any further in algebra or in school mathematics, and therefore and they come to the conclusion that math is hard and that it's not for me, and and so on and so forth. It has to do with the way you were taught it originally, and it goes directly back to the way your domain knowledge of mathematics is represented. Another example of that in mathematics is why kids crash and burn when they hit story problems. Story problems involve transformation of a problem or representation. There are three ways in mathematics involves three languages. It involves representing something verbally in an equation, right? Or in some kind of a concrete representation, a physical object. Well, the problem is there are limits to each one of those representations. Starting with algebra, actually starting with fractions, solving mathematical problems involves transformation. Kids cannot make the transformations from equation representation to verbal representation. And guess what? That means they can't solve a story. They can't solve a story problem because they can't express an equation as a story problem. Most college mathematics and advanced mathematics involves problems that cannot be solved unless you can transform from one representation to another. They cannot be solved. They require that kind of a transformation of the problem. That, by the way, is therefore, if you've never learned how to do that, starting with story problems, you never will be able to do it. Once again, it's a matter of how your domain knowledge is organized. Same thing is true in science. Same thing is true in engineering. Same thing is true in the arts. Even, most arts, many arts, creative arts involve transformation of a representation from one representation system to another. And you're dealing with multiple representations simultaneously. I have a daughter who's a dance teacher, a high school dance teacher, and we've talked about this. And that's one of the main things that she teaches kids to do, is to take things that are into one domain of their life, having to do with their experience and their emotions and so on and so forth, and transform it into another representation having to do with movement and so on. And for the kids, it is when they get the hang of that, it is immensely liberating to them, because it gives them a way to express things that are inside them that they can't express otherwise. So same thing is true all over the place, these transformations, but you can only do that if your domain knowledge is organized the right way.
And therein is one argument for higher education too.
Well, it shouldn't be limited to higher education. This should be started in kindergarten.
True.
Again, it's true at every level. If you wait until higher education, then you have an enormous amount of unlearning to do before you get to the point where you're even ready to talk about to do things at a higher education level.
I'd like to remind everybody to feel free to use chat or raise your hand like Erwin did. If you have comments, observations, or questions for Rob.
Mhm.
I want to take you in a little bit of a different direction, Rob, because I was going to ask you about value, but I think you're answering the questions as we go along with some of these questions, and we're going to see the value, from our perspective in human performance. One of the things you said earlier was that if companies don't, or organizations don't nurture or encourage innovation at every level, they'll die, right? So, that rings a bell to me. The process of innovation are really dear to my heart. So but there's more to it than that too, right? There's what we need to do on the individual side to envision create that kind of thinking, that thought process, as you've been talking about. How do I think that way? How do I look at things that way? But also from the organizational point of view, what do they need to do to learn to see it, to recognize it, to adopt innovation and not stay in the status quo, which I know you said is dangerous. So you want to comment on that a little bit?
Yeah, sure. Again, innovations need to happen, must happen at every level in an organization, which means everybody has to have critical thinking. Everybody has to have a shared common domain knowledge. And that domain knowledge must be organized accurately, or must be organized for the purpose of solving the kinds of problems you wish to solve. And we've already talked about lots of examples where organizing the domain knowledge incorrectly will cause damage. It will prevent you from ever being able to solve problems of the sort that you need to. So that's one issue. So domain knowledge is one issue, but it's not the only issue. Having an organizational culture that pushes information down into the organization is critical, and we've known this now for a generation. None of this is new. But what you have to do is to make sure that everybody in the organization, everybody at every level, understands why they're doing what they are doing, and is given the power, the permission to interpret that and to think critically about it and to think of better ways to do things. And there needs to be that kind of a constant dialogue going on about how are we doing things around here, and why is this the right way to go, and wouldn't this be better, and so on. And it's absolutely critical, and it's true. It used to be a long time ago, back in the days of Henry Ford, only the senior managers had the full view of all of the organization. That is no longer true. And if you have an organization that's like that, or behaves like that, then only the senior managers are fully informed, and so on. That's an extremely dangerous situation, because it will inhibit everybody else in the organization from understanding the business that they are in, and innovating. So that means that there needs to be this kind of constant flow of information in all directions. There needs to be a constant dialogue about how are you going to do things around here, in all directions, and so on. This is absolutely critical. And none of this is new. This has been well articulated for a generation or more, couple of generations now, but we're still seeing it. We still see organizations that function function that way. And once again, my argument is this has to do the training department or the training function in the organization oftentimes simply confines itself to teaching procedurally, teaching compliance, and so on, and doesn't get into this stuff. It doesn't get into asking questions like, is the domain knowledge of this organization structured correctly to facilitate innovation? Are we teaching critical thinking? Are we teaching the kind of problem solving we need to be teaching for people to innovate in this organization? Those are the things that will determine whether the organization is able to adapt and succeed not the stuff that the training department usually spends its time on.
Yep.
Corollary, the training department is working on trivial stuff.
So how do we make the case, right? I mean, how do we express that value to our organizational leadership? How do we, and this is an investment because it is harder to do. Learning is hard, but doing it in this method is harder. It's got definite increased value. So what is the case that we make as, you know, trying to influence our leadership to adopt this way of thinking, you know, both as we're helping people learn, do new skills, whatever it is, to do it this way, but also to make sure the organization is receptive to it, ready for it, and able to take advantage of it?
Yeah, that's a really good question. Lots of senior managers in organizations and experts, senior technical experts in organizations will tell you flat out to your face that what they know how to do can't be taught. And the rule of thumb is it takes 10 years of experience to learn how to do this, to learn how to do what I do. You know, whatever it is. And there's actually been some research on that, and the answer is no, you can't get rid of that 10 years entirely, but you sure can cut it down. Yeah. And you can also make it much more replicable than it is now. So that's, you know, that's one issue. Give you a war story. I once worked with a global marketing organization. By the way, everybody in charge, all the senior managers were mathematicians. And and as a result, it was the most data-driven organization I have ever seen in my life, which made it wonderful to work in, because they were, you know, because they wanted to measure everything and count everything, which meant therefore that they had all kinds of performance measures just floating around inside the company that they didn't know what to do with. Anyway, so they had a problem. The problem was, okay, they have their most senior account executives held the title of VP, and they dealt with accounts that had values in the millions of dollars worldwide, and they dealt with global Fortune 500 and size companies. But they observed something about this, and that was that all the people who were doing those jobs who were performing at that level were doing it differently. And there was very little learning going on from one person to the next about how to do the job, and so on. And so we got to investigating a little bit and came to the conclusion that there was no shared domain knowledge of how you solve the problem of growing an account at that level. And so on. So we started saying, okay, this is a quantitative organization. We're going to start by measuring. We're going to measure that proficiency in that kind of problem solving. And the simple, first of all, they said, you can't do it. It's impossible. So we did it. We produced a performance-based measure and demonstrated that and validated it on about a dozen of these people worldwide, and so on, and so on. And then we were able to predict who was going to be able to grow their accounts and who wasn't. And they were able to say, okay, all of them grew their accounts, but the ones that did the best job on our test grew their accounts by like $4 million versus $1 million or whatever. And that kind of a thing over a period of about 3 years. And so that got their attention, and so on, and from there on the doors were open, because we had defined what the problem-solving process was in the course of doing what was basically a classical cognitive task analysis for an ill-structured, complex, ill-structured domain, and we had developed a measure, started out by developing a measure, and then we were able to demonstrate the validity of the measure, and that got their attention. And then all of a sudden the doors were open. So
wonderful.
that, that's one example.
Rob, we
Give
had
the
a
others.
hand up from
You're
Nerdan
done.
here.
Yeah.
Thank you. Thank you. I was waiting for Rob to finish and I would jump up. So thank you. I'm from Canada, London, Ontario, Canada, and I'm very happy to be part of this group and a lot of knowledge experience. So that is so nice to be here. Thank you for including. So when I talk about inclusion, I think what you're all talking about, Rob, comes down to psychological safety. If you want people to have the creative thinking, if you want people to be able to innovate, in my terminology, I use reinvent. If you want people to do that, then you need to include one thing. You need to give them the learner safety so they're able to learn to come to a point. And then they can contribute with that knowledge. And then they can start solving problem. And the threshold of innovation is when you let them to challenge the status quo. So if you do not take your culture through this and bring people to this level, they can just talk about creativity. They can talk about, oh my goodness, critical thinking. We want people at every level always. But are we really supporting it with us? So with my clients, in a recent example, I was talking about this psychological safety, and he just said, we are encourage them to innovate. And then I corrected it, reinvent. Innovation is a different thing in organizations. If we want everybody to find a better way of doing things, it's not innovation, it's reinvention. In the global population, only 2.5% of people are real innovators. So if you just bring this down to an organizational level, you just see that maybe you have only 1, 2 real inventors, innovation people, which is not really solving the problem. We want everybody at every level with every task they're doing, they should be able to reinvent and do those tasks more productively. So then I just corrected it and he just got a little bit nervous. And then he said, we are sending memos out there, people to think. But then in a meeting I was sitting, nobody was able to talk. Nobody was able to bring the ideas out.
Yeah.
They're pushed down. And then after that, I talked to the CEO. I said, if you ask my observation, you will never get to that point because what you're doing and what you're saying are not
Two different
aligned.
things. Yeah.
So
Right.
I just wanted to share that example.
Absolutely
Thank
correct.
you.
Couldn't agree more. You have to have a culture in which if you punish failure in the organization, then you will inhibit innovation. No question about it. That's also called growth mindset.
Yeah.
Go ahead, Max.
Max.
Off mute, though.
Yeah, unmute. So it seems to me, and Rob and others can confirm this, that you almost have to have an initiative and you have to have teams that are tasked with innovation, with continuous improvement, with, asking the hard questions. And you'd have to have this at your strategic planning level, at your at your C-level, corporate level leadership, and at all levels, that they're actually tasks. And then, like Nerdan was saying, there has to be psychological safety. You have to have courage and empathy and curiosity all combined, and willingness to have each other's backs and listen to each other and have divergent and convergent thinking. But this doesn't happen very often. I mean, this is very rare in organizations. But
one of the standard pieces of strategies for that is to create a Skunk Works. You have to create, if you want an innovation to occur, create an organization that is independent of the main organization. And because main organization will tend to suppress, lots of times suppresses innovation because they want to regularize procedures and they want to proceduralize everything. And if something doesn't look like a procedure, it's dangerous. And so on. Then you have the problem of transition. However, how do you get the innovation out of that Skunk Works and into the organization? There are people who say, by the way, it can't be done, that the only thing to do is to gradually grow the Skunk Works into a new organization and let the old one wither and die. Edgar Schein, my favorite guru and great, famous organizational development expert, and so on his book on culture change in organizations, said that in his entire career, he had never seen an example of a culture change. Not one. What he has seen are organizations that rebuilt themselves from their core values as defined usually by the personality of the CEO. And so you can do that, but you can't. But a real fundamental culture change, you really, he'd never seen an example.
Rob, we have a good question here from Jennifer in the chat. I'm going to read it real quickly. So how do we apply this to training instructional designers how to design solutions? They know how to develop, meaning they can take a storyboard and use an authoring tool to create a program, but I find very few instructional designers who can set goals, establish a data gathering methodology, look at the data and make recommendations, then design a program that meets the goals. In my own experience, one of the strengths that I brought to instructional design was that I was a proficient or expert in the field that I was training in. And I think that's the missing piece of the puzzle, if you will, for instructional designers that come in who don't necessarily understand the technology to a sufficient depth to do what she's just describing. Because I've done exactly what you've described here, Jennifer. And it's not easy, but it's doable. But it requires that you know the technology you're working with to a greater depth.
And Jennifer, feel free to come off mute, I would say, but Rob, go ahead.
Yeah, absolutely correct. What you're saying here is that the combination that you are most valuable to your organization if you have a combination of domain knowledge in the organization, the organization's domain knowledge, and your knowledge of instructional design, because then you can merge the two, and that makes you valuable to the organization. If all you come in with is just instructional design knowledge without the domain knowledge, first of all, you need to be on a very fast learning curve, but that's true for instructional design anyway. You have to be on a very fast learning curve, but you will be less valuable to the organization until you do. Now, having said that, I'll give you a war story of exactly the opposite. This is one that's actually happened to me 2 or 3 times in my career. I once waltzed into a network software company. Trust me, I have beyond Fortran. I never Fortran and a couple of other programming languages. I'm not a programmer. Certainly not a practicing programmer. I had a little bit in college, and that's about as far as it goes. And so on. So the problem that they had was that this organization was, this company was about to launch a competitor to what we now know as Microsoft Teams. It had a different name back then, and different organization. But anyway, that's in modern terms, that's what it would be. And so on. And the challenge that they had was that they had 175 field engineering network people who are used to dealing with network software, who had the challenge of learning how to install and troubleshoot the installation of the system. And the training organization had done exactly what you should do if your training is in Mager, task analysis, and ADDIE. That is to say, they had defined all of the tasks involved in installing and troubleshooting, and they developed a procedure for every one of them. The problem was that there were 475 of them, and they had 1 week to train these guys. And so, so the question was, how are you going to do that? And that was the point at which I got called in. And so I got to thinking about that. So I started asking a few questions, and sat down. Well, to make a long story short, we sat down, me and 2 other guys, 2 other people, senior people, and a whiteboard. And it became apparent that that every installation, regardless of the installation, one of the things that was throwing them was that every installation of the system was going to be different because every corporation was different, and the way you installed it depended on the way the organization was configured. Okay, but as it turns out, there were only about a half a dozen modules in this system. And you installed those modules you replicated those modules. So there was more than one instance of each module, but you installed these modules as needed across the system, and in order to get to a complete functioning system. Okay, so the first task was figuring out how many of these modules how many instances you needed to install in order to adequately map the system. But then the rest of it was troubleshooting. So let's talk about troubleshooting. Well, it turned out that of those half a dozen modules, that all of the error messages that the field techs needed to be able to deal with had to do with problems of communication between those 6 modules. And so I got up on the whiteboard a diagram with 6 boxes. And the first thing they said was, my God, you realize you're only the 4th person in the company to draw that diagram? And I said, why on earth is that? Everybody should have this in their mind. First issue. Second issue, okay, let's validate it. Give me any error message that you would expect a network field technician to handle. And I will tell you what communication problem caused it.
10, 11.
Mind you, I'm not a programmer. I am not a network engineer. I have never seen this system, but you just give me the message and I'll tell you which 2 modules can't talk to or are having a problem talking to each other. So they did. They gave me about a dozen of them. And I said, okay, that error message is probably caused by this module, which is sending incorrect data to that module. The incorrect data is probably the result of some configuration problem or something like that. And their jaws dropped. So they did about a half a dozen times and said, and then they were satisfied and said, okay, this is really going to work. Now, then I asked the next question, which was, okay, now your network engineers know an awful lot more about how networks work than I do, and they know how to install networks and I don't. So you don't have to teach them that stuff. All you have to teach them is what the rules are for putting those modules where they need to go, and give them enough practice with interpreting error messages so that they can do the exercise I just did. Only and actually fix the problems. How long do you think it would take them to do that? Well, we could probably, at the level of expertise that they have, using the knowledge they already have of how networks work, said, well, I don't know, it might take a day. Okay, and you give them another day of practice, troubleshooting. Okay, that's 2 days. Now, what were you planning on doing the rest of the week?
Yeah.
In 2 days of training.
So Jennifer, I want to make sure that we got to the essence of your question, but I will comment that some of how to teach this was in Rob's last session with us. And when we send out the link to the YouTube and everything from this session, we'll include that information as well. But I want to give you a chance to ask a follow-up question or make a comment, Jennifer.
Sure, thank you. Can you hear me okay?
Yes.
I don't have my headset on, so.
Good.
Anyway, yeah, my question was really more, and Rob, you answered it in that those are the exact same types of things that you taught me to do in the late 80s, is take a bunch of data and analyze it and figure out a better way. Right?
Do you have any idea how proud that makes me feel?
No.
Well, I hope it makes you feel very proud. Do you have tears in your eyes, Rob?
Yes, I do.
Okay. Yes, I learned that from you and a number of others in our applied learning environment many years ago. And I can tell you a story about how I applied it in a similar situation. I was responsible for creating a training program for security officers who work in hospitals across the country. I no longer work in corporate training. I train industries. And so in this case, it was pretty much every security officer in the United States and other countries takes this training program to learn how to do to provide security in hospitals. And they had a giant manual. And I was supposed to develop an e-learning program that basically, took this manual that, that basically was huge and would take forever, and they would fall asleep listening to if I put it in an e-learning program. But instead, what we ended up doing is having a brainstorming session with with a bunch of subject matter experts and people who work for the association, and did something similar. We created a flow chart, an algorithm, and we taught to the algorithm. And you know, and in doing that, we got this thing down from, you know, to basically, I think it's now a 20-hour program instead of being 60. So yeah, but anyway, but my question really is around, I'm having trouble finding instructional designers that can do that. As a business owner who owns a business that creates e-learning program and provides this type of value to my clients, I am having trouble finding instructional designers that can do that. A lot of my colleagues, imagine this, are retiring. My colleagues who know how to do this. So, you know, how do we train the next generation of people to do this, to do what we do?
Yeah, that's a really good question. That's one I actually stew about all the time, because I'm now mentoring doctoral students in 2 instructional design programs and or education technology programs at 2 universities. And I've asked myself exactly that question repeatedly. I think, you know, as long as because you know, instructional design at the practitioner level is a master's degree field. It is, and if all we do with our master's degree students is to teach them Mager style task analysis and ADDIE, we have caused damage, because we will inhibit them from ever figuring out how to do this stuff. And so that's a real challenge. Now, there are other ways of teaching instructional design, of course. And one of the ways that has been experimented with some is called a design studio. For example, in which you have you do a group design activity spread out over a period of days, very intensive typically, which you taught you work on a design problem, but then you also call a timeout and talk at the metacognitive level about what you just did and what needs to happen next, about how am I thinking about this problem, and so on. By the way, you will notice that we did exactly that at Applied Learning. When didn't do it often enough, but I wanted to do it, and I wanted to do it more. But every once in a while, the designers would all somehow or other wind up in the same meeting room, in a room that was surrounded, where every wall was a whiteboard, and we would work jointly on a problem, and on a design problem, and
That's
talk
where
through
I
how
learned
to.
my methodologies.
And that, yeah, right, exactly. That is the design studio approach, and that's why we were doing that. And it's quite feasible. You can do it in a master's level program. People don't, but you could.
No, they don't.
Or it's rare to do it at the master's degree level. It's a little more common at the doctoral level, but that's a damn shame, because it needs to happen at the master's level in this field.
Rob, I want to interject here. I see that Nerdan has her hand up. Let's cover that comment, and then we're really close to 1 o'clock. I know that people need to cut away at 1, so Nerdan, floor is yours.
Yeah, very, very, very quickly. I think the ADDIE methodology is fine if it is done in little circuits in an agile form.
Iterations,
so you can still do your ADDIE, but in shorter terms of testing, doing and testing. So that's agile. That's one thing. But I think the goal of the training programs in the organizations, as a former learning and development and instructional designer person before my human performance business, I think the goal is developing the critical behavior. If we want to sustain that result to go on forever. So as an instructional designer, when you think about your programs, I talked about this in the last International ISPI conference, how we can change learning into habit building. And if you want to watch that, maybe then we can or connect with me. I can talk more about that. But the point is, if you can build that behavior change, it's not the information you're giving. And from the Bloom's taxonomy, there are different levels of thinking, the knowledge and the comprehension and application. When you come to that application, you need to explain them that behavior, and they need to practice that behavior over and over and over. And in the organizations, one trick is that when they get that information, they don't have the environment and the support and the coaching from the leadership to practice that behavior and develop that. So just pouring a cognitive load, just giving that information out there in a week or so, just giving the whole thing, how would you expect they pick the critical behavior, what they need to do, and build on that? So when you design your programs, this is how I work with my design team. When you work on those critical behaviors from the business results come. So what is the business result we want to see? We want to increase our sales this much and blah, blah, better customer satisfaction, better customer service, whatever it is. So what is the critical behavior that will develop that result? Okay, for that behavior, what is the content and the delivery method we need to go? So if you start from the back, from the business results and come to your training, then that will help the design. Just a little input. Thank you.
Begin with the end in mind. Yeah.
So
Great.
I want to thank everybody who asked questions, made comments. Rob, just many, many thanks for this. It's really compelling. I think it's an area that is really underserved in this area. How do I know what I know? How am I thinking about this problem? Not just thinking about the problem, but how am I thinking about the problem? It is just so wonderful. And like I said, we will send information from the last session with the link for this YouTube as well. This was a lot here. I was really wanted to dive in more. I think we could go a couple more hours, but unfortunately we can't. Miller, we're ready to end the meeting.
Yeah, I know.
Again, thank you, everybody, and most especially thank you to Rob.
Yes,
Thank you.
thank you all.
Good
Okay.
conversation. Thank you.